Hi, how are you? My name is Paul Pancaran Situmorang. In this procedural literacy, I will highlight about the assumption 1 year experience in object-oriented coding vector arithmetic. I will introduce to you about GSAP, yield, coroutines, game mathematics, and literacy. Imagine you have a spread game object and you want the ball to flash blue and red. In the start function, we set up the color attribute with an array containing the color red and blue. We set up the material attribute to be a pointer to spread material. Each frame up that we cycle through the array of colors. We set the spread color to be red and then wait a half second. When then the spread color to be blue and then wait another half second. Finally, as update ends, a draw count is made. Consequently, the blue is only ever blue and there is a significant lag. In the start function in this version, we set up the color array and the material pointer, just like we did in the native attempt. Next, we start the coroutine flash color. Inside flash color, we set the spread color to red. Next, the yield start and return control to Unity. At this point, numbers update calls are made while the coroutine waits for a half second. Note the F at the end of 0.5 is to the net offload. On my machine, over 30 updates call and associated draw calls were made. Control is returned to the coordinate, whereupon the ball is changed to the blue. The coroutine is paused for another half a second. Finally, when the coroutine obtains control again, it could safely restart the flash color coroutine. Although Unity performs many of the complex object manipulation for you, a good understanding of vector is important, so you can effectively use the functionality. Here, we will cover a quick refresher. The 2D point has an X and Y coordinate. Unity uses the left-handed coordinate system, which meant the X-axis extends into the screen rather than out from the screen. The 3D point key can be represented by the point 2, 2, 2. Alternatively, it can be represented by the point 2, 2, 2, 1. We will see later how adding the extra allows us to use metric multiplication to translate points. A vector is retrieved from one point to another. It is denoted by an arrow. Assume the vector phi is the trip from point P 2201 to point T 2221. To calculate phi, we subtract the starting point P from the destination key. Open-wise subtraction shows that phi is vector with a z-axis displacement of 2. In Unity, you can find the displacement with vector between two game objects Q and P by subtracting their transport position. In Unity, position have a vector type. Positions are considered vector from the origin. As such, you can obtain a vector W by subtracting the vector 2 to O from a position key. A vector has a length or distance. In Unity, write the magnitude attribute of a vector to obtain its length. A vector has a length and a direction. A unit vector is a vector of length 1. A vector phi can be normalized so that it becomes a unit vector phi. The normalized vector phi has the same direction as phi, but it has length 1. A normalized vector phi is calculated by defining the vector by its magnitude. Unity write the normalized attribute of vector to obtain a unit vector. Unity provides a number of unity vectors that have the same direction as their axis, for example, vector 3 dot forward. Imagine you are playing a game like Mario Kart. If you drive over a power-up track, on you will receive a boss. If you drive over a power-up at an angel, you will receive less of a boss. Vector dot product or scalar product can be used to find an angle between two vectors. That vector is defined as a scalar pointwise multiplication. V.W is equal to 16. Dividing both sides by W gives 2. Using some trigonometry magics, the dot product is also the product of the magnitude of the vector by cosine of the included angle of. This is the magnitude of the projection of V onto W. Since W is along the x-axis, in this case, it is simple the x-coordinate of V. You have a racing car game object. You make use unity dot function to determine the magnitude of the velocity of the car in the direction that a power up is facing. If the dot product of the vector is O, we know that the vectors are perpendicular. Physically, this is analogous to the projection of the y-axis on the x-axis. A light becomes off or white would sign on the x-axis. Rearranging the dot product formula allows us to calculate the include of angle O by taking the crossing of dot product of unity vector. Unity looks at function use vector dot product. Look at can be used to have one game object turned to face or look at another game object. Given two vectors, a perpendicular vector can be found using cross product. For left-hand coordinate systems such as unity, use the left-hand rule to determine the directions of the perpendicular vector. From your maths, you may remember concrete triangles, and rigid transformation is used to transform one triangles to concrete triangles. A rigid transformation allows only rotation, translation, and sometimes reflections. There is no squashing, sharing, scaling, or other deformation allowed. In physics, a rigid body is a solid object in which deformations are ignored. For maths, you may also remember similar triangles. Similarity transformation also allows scaling. These are the transformations that we will cover today. Affine transformation also allows sharing, kind of like push over rectangle. Projective transformations are used for perspective camera views. A game object can be moved using the translate function. This command will move the object 2 units to the right along the x-axis and 2 units forward along z-axis. This 4 multiplied 4 metric can be used to perform translation where the triangle values are the x and y and z translation. Earlier we note that sometimes a 3D point such as 444 is represented as 4441. This representation allows us to use metric multiplication to perform translation. We insert the translation vector 202 into the translation metric and pre-multiply by the origin point 444, performing the metric multiplication result in the point 646. A game object can be rotated using the rotate function. This command will rotate the object 900 degrees around the x-axis. Using the left-hand rule, we can see the cube will rotate forward or away from us. There are different rotation metrics for x, y, and z roles. Here we have the x roles rotation metric. Have a look. A game object can be scaled using the local scale attribute. This command will double the scale of the object 2 units to the right along the x-axis and 2 units forward along the z-axis. I think that's all, and thank you for your attention. Goodbye. Cheers.